All right, let's jump right in. Today we're going to unpack a really fascinating climate puzzle. It's this planetary scale coincidence that, honestly, has had scientists scratching their heads for decades. It's a story all about a perfect balance that's found in one of the most chaotic systems we know. So here's the mystery at the heart of it all. Satellites have confirmed without a doubt that Earth's northern and southern hemispheres reflect almost the exact same amount of sunlight back out into space. They call this albedo symmetry. And right off the bat, that should sound, well, kind of weird, right? Because it makes almost no sense. I mean, seriously, just think about the globe for a second. The northern hemisphere, it's basically the land hemisphere. It's covered with continents, forests, huge deserts, all our cities, which of course means more pollution and aerosols in the air. Then you have the southern hemisphere, the water hemisphere. It is completely dominated by the vast, dark expanse of the oceans, and it has way more intense storms and much cleaner, more pristine air. They are fundamentally completely different. So how on earth could they be perfect mirror images when it comes to reflecting sunlight? This perfectly balanced puzzle is a super critical feature of our entire climate system. But for the longest time, the actual mechanism that maintains this albedo symmetry has been a total mystery. Well, the key to the whole thing, as you might have guessed, is clouds. They're the great equalizer in this story. But how they managed to pull off this incredible balancing act has only really come into focus recently, and it's all thanks to a brand new way of looking at them. So to crack this case, scientists over at NASA developed a new kind of investigative tool. Instead of just looking at individual clouds, they came up with a system to classify entire cloud systems based on how they behave through the seasons. Okay, so the name is a bit of a mouthful. Regimes of regimes, or RORs for short. But the idea behind it is actually pretty simple and honestly kind of cool. You can think of it like scientists decided to give clouds different personalities. The entire planet's cloud cover has been sorted into 8 of these distinct RORs, and each one represents a specific mix of cloud types that acts in a certain way over a season. So, for example, you've got ROR2. These are the thick, sprawling clouds you always find in oceanic storm tracks. Then there's ROR4, which is more typical of the mid-level clouds you see over continents. ROR5 captures those really persistent, low marine clouds, kind of like the ones off the coasts of California or Peru. And then you have something like ROR8, which just represents the very sparse, wispy clouds you'd find over a desert. Each one has its own unique job in the climate system. And this is where we get to the absolute heart of the matter. The solution to this whole puzzle isn't that the clouds are the same in both hemispheres. No, not at all. The balance comes from a perfect cancellation of massive, massive imbalances. Using this new tool, scientists found something fascinating. These individual cloud personalities are wildly asymmetric between the two hemispheres. For instance, ROR4, those continental clouds, are way more common in the land-heavy northern hemisphere, so they reflect a ton of light there. But then ROR2 and ROR5, the oceanic, storm, and low marine clouds, are way more common in the ocean-heavy southern hemisphere, making it super reflective from their contribution. And here is the punchline. It's the magic trick. When you add up all those huge opposing imbalances from all the different cloud systems, they almost perfectly cancel each other out. They just vanish. The total difference in reflected sunlight between the two hemispheres is less than 0.1%. It's this accidental, almost elegant equilibrium. You know, the researchers themselves put it perfectly in their paper. They said these uneven contributions cancel each other almost exactly. So it's not about symmetry at the small scale at all. It's this grand planetary balance that's achieved through opposing forces. But of course, there's a twist. This perfect balance, it turns out it isn't necessarily permanent. A recent analysis of more than 20 years of satellite data is showing that this delicate equilibrium is actually starting to shift. What's happening is that both hemispheres are getting darker, which is just a way of saying they're reflecting less sunlight than they used to. But they aren't darkening at the same rate. The northern hemisphere is dimming quite a bit faster than the southern hemisphere. And you can see it right here in the data. Between 2003 and 2024, the northern hemisphere started trapping about 1 extra watt of energy per square meter every single decade. The southern hemisphere is also dimming, but at a slower pace of about 0.6 watts. The perfect symmetry is starting to drift apart. So what's driving this change? Well, it all comes back to those cloud personalities. A key player here is ROR5, Remember those super reflective low marine clouds? Well, their populations are actually shrinking all around the globe, and that's a big part of why the whole planet is dimming.
But reflected light is only half of the story. If we really want to understand the planet's energy budget, we also have to look at the energy that isn't reflected, the energy that gets absorbed. And this is where we find a whole other layer to this puzzle.
Now, at first glance, it looks like the exact same story. I mean, it makes sense, right? Because the hemispheres reflect the same amount of sunlight, they must also absorb the same total amount of solar energy. And they do. It's another perfect 50-50 split. But here's the really critical follow-up question. Where exactly is that energy getting absorbed? Is it happening at the surface, in the land and oceans, or is it happening up in the atmosphere? This is where a crucial hidden asymmetry reveals itself.
The southern hemisphere, which is dominated by all that dark ocean water, absorbs way more solar energy at the surface than the land-heavy northern hemisphere. But since the total absorbed energy has to be equal, that means its atmosphere must absorb less energy to balance the books. And the northern hemisphere does the exact opposite. Its surface absorbs less, so its atmosphere has to absorb more.
And the numbers here are really significant. The southern hemisphere's surface absorbs about 4 watts per square meter more energy than the north's. Now, to put that into perspective, that's roughly the energy of 4 standard nightlights over every single square meter of the southern half of the planet. So, to keep the entire planet in balance, the northern hemisphere's atmosphere has to absorb that exact same amount more than the south's. It's another one of these beautiful hidden balancing acts. And look, this isn't just some neat piece of climate trivia. This fundamental imbalance in where energy gets absorbed, either at the surface or up in the air, is a massive driver of our global climate. It influences everything from atmospheric circulation to our weather patterns and even how heat gets transported across the equator. So we're left with this incredible picture of an accidental, multi-layered balance created entirely by clouds. But as we've just seen, that balance is already starting to shift. And that leaves us with the final and most crucial question. As our planet continues to warm and cloud patterns keep changing, can this perfect symmetry possibly hold? And what happens if it doesn't?